Hello, welcome back to my channel Study with me. This time I will explain subtopics 112 and 113 from structure 1.1 and the first theme, models of the particulate nature of matter. So these two subtopics, it's about the kinetic molecular theory and kinetic energy and temperature. So from these subtopics, you need to know how to distinguish the different states of matter. Also use state symbol as solid, L liquid, G gas, and AQ aqueous in chemical equations. You also need to know how to name off the changes state like melting, freezing, vaporization, evaporation, boiling, condensation, sublimation, and deposition. Let's start with the kinetic molecular theory. It is a model designed to describe liquid, solid, and gas properties that depict all matter as composed of constantly moving particles, hence kinetic term is used. In this figure, you can see how solid particles, liquid particles, gas particles are arranged. So for solid particles, there is no gaps between the particles because they are generally regularly arranged due to relatively strong forces of attraction between the particles. Therefore, they're only able to vibrate about mean positions and have fixed shape. And for the liquid, the attraction of forces, are weaker compared to that in solid. So the particles are able to move around each other. So they follow the shape of the container, but they don't feel in the container. It's totally different with gas. When the attraction of forces, there is no attraction forces between gas particles. So they're able to move freely in all direction in the container. So they feel in the container. So that's how the particles of gas, liquid, solid are arranged, and they represent the properties of the three states of matter. Next, changes of state. Right. They are melting, freezing, vaporization, and condensation. So vaporization, there are two, boiling and evaporation. So when the energy is transferred into solid particles in the form of heat, when you heat up the solid, then the heat energy or thermal energy will transfer into solid, then it becomes kinetic energy for the particles. So the particles that are able to vibrate only before, which is they are solid particles, right? And now they're able to move around each other because the energy increases, the kinetic energy increases, right? And the process is called melting. And this occurred at melting point where the temperature at which substances change state from solid to liquid. And you heat them up more, the liquid particles, now it gain more energy and now can move faster and change the states, become gas through boiling and evaporation. Evaporation and boilings are not the same thing. Evaporation can occur at any temperature between melting and boiling point. And the bubbles that are formed only on the surface. But boiling, no, the bubbles that are formed throughout the liquid, and it occurs at a fixed temperature, which is boiling point. So the boiling point is the temperature at which the vapor pressure is equal to the external pressure. So when the vapor pressure reaches the external atmospheric pressure, the liquid boils. So from solid to liquid, liquid to gas, they gain energy, the temperature increases. And the opposite, gas to liquid, release the energy, liquid to solid, release more even energy. So from gas to liquid, it's called condensation. From liquid to solid, it's called freezing. For sublimation, from solid to gas, skipping liquid. And the opposite, from deposition to sublimation, liquid also skip. Next, state symbol in equations. There are S solid, L liquid, G gas, this should be L, okay? AQ, aqueous, dissolve in water. So by looking at these equations only, we know that this one is solid water, so it's ice cube. Change into liquid water. And here, bromine liquid, okay? And change into bromine gas. And this one, iodine but solid, and change into gas state. It's called sublimation because there is no liquid directly from solid to gas. Use the kinetic theory to explain whether you would expect the rate of diffusion in the liquid to increase or decrease as the temperature is increases. All right, so diffusion. The particles spread around. So the average kinetic energy increases with temperature. The particles will move faster and the rate of diffusion increases. Which is the correct descriptor for the movement of particles in the solid, liquid, and gaseous state? Solid, the particles can vibrate. Okay, so vibrate. So this one, no. And for liquid, not vibrational, but limited movement. They move around each other. And gas, free movement, not vibrational. So the answer is D. A beaker containing solid carbon dioxide, solid, CO2, is placed in a fume cupboard at room temperature. The carbon dioxide becomes gaseous. So from solid to gas. From solid to gas, it's sublimation. From gas to solid, it's deposition. Okay? Water exists in 3 states, ice, liquid, and steam. Which transition can occur over a range of temperature at constant pressure? So freezing, melting, and boiling occur at a fixed temperature at a given pressure. Evaporation occurs over a range of temperature. So the answer is C. Next subtopic, structure 113, where you need to know how to interpret observable changes in physical properties and temperature during changes of state. Convert between values in the Celsius and Kelvin scales. The Kelvin, K, is the SI unit of temperature and has the same incremental values as the Celsius degree. In science, the Kelvin scale is commonly used because it's an SI, okay, the global standard for scientific unit. Start at absolute zero, the lowest possible temperature, like when there is no kinetic energy, so there is no collision, okay? So absolute zero, the lowest temperature possible, corresponding to 0 Kelvin. So 0 Kelvin equal to minus 273 minus 15 degrees Celsius. So 273, so for 1 degree Celsius, 0 degree Celsius, 0 degree Celsius equals to 273.15 degrees Celsius. And the increment of 1 degree Celsius is the same as the increment of, or the change of 1 Kelvin. For example, okay, temperature, okay, delta T, T1, 30 degrees Celsius, T2, 50 degrees Celsius, and T1 here, 273 point, let me just give it another number. For example, 400 30 Kelvin, and T2 460 Kelvin, for example. So this one 30, 20, and this one also 20. Or let's just convert when we add this, okay, to 273, right? So this would be around T1, so 273.15. That would be 303.15 Kelvin, and this one 273, so that would be 323.15 Kelvin, right? So the increment here is 20, right? 20, and this one also 20 degrees Celsius, this one 20 Kelvin. So this is what it means. A change of 1 degree Celsius is the same as change of 1 Kelvin. Right, so now the heating curve. Let's talk about the heating curve. Right, so solid to liquid to gas. So when we heat solid, the particle of solid vibrate more, gaining kinetic energy, right? So the temperature of solid rise from 20 to 50. At 50 degrees Celsius, solid starts melting, but liquid and solid still present. So the temperature here remain constant during melting because the heat that is used to heat up this from solid to liquid is used to overcome particle attraction, so allowing particles to move. So at melting point, energy increases, potential energy also, but not kinetic energy. So after all solid melts, heat energy raises kinetic energy of liquid particles. So now goes to here. All right, so the temperature increases up to 80 degrees Celsius. So the here flat also still the same right here. So the heat energy overcomes particle attraction in liquid. So temperature remains constant until all liquid turns into gas. So we keep heating up these substances, okay? This substance. So when we continue heat, the kinetic energy increases and you form all particles from solid to gas. The temperature raised even more than 80 degrees Celsius. Right, so now let's do the simple calculation. So let's convert each of the following temperature in degrees Celsius to temperature in K. You can do this, okay, by yourself. I will help you to do this one. So 35 degrees Celsius, we convert into Kelvin. So we add 273.15. So that would be 308.15. And this one also 273.15. We add them up, it becomes 773 Kelvin. You add 273, 273.15, 273.15. Okay? And for this one, minus 273.15 from Kelvin to degree Celsius. So that would be 50.15 degrees Celsius. And for this one, minus 273.15, so would be negative 165 degree Celsius. Right. Which of the following occurs at the freezing point when a liquid is converted to a solid? Kinetic energy of the particles decreases or separation between the particle decreases. So when the freezing point, when a liquid is converted to solid, liquid to solid, it loses the energy. The temperature decreases. So the temperature decreases, the energy decreases because lose the energy. And the separation, now this here right? The particles move around each other, and this one vibrate only. So the separation decreases as well. There is no gap, like, here. Okay, so the separation decreases from liquid to solid. Therefore, 1 and 2, correct. So C. The objects made from different masses of iron have the same temperature. Which of the following is correct? Comparison of the average kinetic energy and the total energy of the atoms in the object. Right, so as they have the same temperature, the average kinetic energy of the atoms is the same. So the object with a larger mass contains more atoms, so has the greater total energy. Therefore, the answer is C. Okay, so we just talked about the kinetic molecular theory and kinetic energy and temperature. Now, let's see the linking question. Right. Why are some substances solid while others are fluid under standard condition? Okay, so some substances solid while others are fluid under standard conditions are influenced by several factors, right? Like forces, molecular structures, and temperature. Okay, so particles of solid are held closely together, resulting in a fixed shape and volume, while liquids have weak forces which allow them to slide past each other, resulting in a definite volume but no fixed shape. So the molecular structure influences the atoms' arrangement and behavior of substances, which in turn affects their physical states, such forming rigid lattice structure because they have regularly um, arrangement, okay? And they are regularly arranged, the particles. So resulting in solid shape and symmetry allows molecules to pack closely. And polarity, leading to have attraction, where stronger attraction in liquids and weaker in gas. Why are some changes of state endothermic and some exothermic? Endothermic would lose the energy. And lose the energy, for example, endothermic gain the energy. For example, from solid to liquid to gas. And then exothermic release the energy. Okay, so why are some change of state endothermic, some exothermic? Because some of them gain energy and some of them release the energy. The one that gain energy, the change of state from solid to liquid, liquid to gas, and then exothermic from gas to liquid and liquid to solid. All right, so that's all for our subtopic 112 and 113. Thank you so much for watching. If you haven't already, please subscribe to the channel and do not forget to share it with friends who might benefit. Be sure to join the WhatsApp and Telegram channels to stay updated on the community, where I plan to hold live classes, answer your questions, and work through IB style exam questions for each topic. Your support means everything. See you in the next video.